Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back to another episode. So we'll see how things go today. So we got some kind of interesting questions. We got some stuff we get to take apart, things like that. First one is on 3104 series replacement. You want to pop up the first graphic? We're getting the graphics pretty early here. Mm-hmm. Here's a photo we got from a customer of a very old regulator. This is probably something from the 80s, maybe 70s, that regulator.
Older than me.
It could be. So they want kind of a replacement for it. So it's the 3104 series. And you can see it's got if you would to look at our online store, we've got the old regulator guide.
Yeah, we have our old regulator.
You'd say, oh, the 1250 is your closest replacement, because this one is a forged brass body, two-stage with a stainless steel diaphragm. And that's what the 1250 is, two-stage forged brass stainless steel diaphragm. But they've got a couple other things going on here. One is the interstage relief valve. You can see that pointed out, and that's piped away. And then they added a low pressure relief valve, which means they want an extra, and they've got it piped in. The 3104 as an extra low pressure port on there. And that looks like a swage lock, I don't know, one of those swage lock relief valves.
Mm-hmm. Little pop it check valve.
Yeah. It's kind of nice. So you can take away the graphic and then we'll start looking at stuff. So this is the 1250 series. It's forged brass, two-stage. You can see because it has extra stage sticking out the back.
Big rear end.
It's a stainless steel diaphragm. We're not taking this one apart because this came from stock to show you that. But you want to zoom in, and it's got one extra port there, and that's an interstage port. So you can put in an interstage relief valve. But there's no other low-pressure ports in there. So you want to zoom back out. Now, if you go to our 3120A series, that's brass bar stock, so it's a higher purity brass. Two-stage, and it's got stainless steel diaphragms. You want to zoom in on it again? Okay. Down here, I got to look from here.
That's the low.
You've got an
high. Okay, yeah, the interstage.
That's looking at things backwards here. This is the interstage port, so you can put an interstage relief valve in there, and there's a low pressure port. So if they still want a low pressure port, this is probably their best option if they want to pipe in a relief valve on that. Want to zoom back out? But if they really wanted to go with a 1250, they'd say, oh, I really want to have that body. It's perfect. It looks great. It's going to work for my application.
I like black knobs more than blue knobs.
Yeah, something. For whatever reason. We could put in a street tee in here between the body and the valve, and it pushes the valve out. So they're going to get a different profile in their setup.
So instead of it coming out of the bottom at an angle, it just comes straight down.
It might be a little tough for them to fit all that in there. But if they wanted to go with that, we can do that by putting a street tee in here and then pipe it in a relief valve.
It is an interesting one. You don't usually see a low pressure protection like that, right? I've not seen it that often.
You really don't get many of those. That's a good point to bring up. We don't get many of those. Some usually handle them with dash S's or modified regulators. But yeah, we don't really get that often.
No.
So.
Or people are taking that cap off and doing it anyways, and we don't realize it. They're not asking us for it.
Yeah, they might be piping it in themselves anyways. So that's it for that question. This next question gets a little complicated. It's longer. I'm looking at your 6290 series excess flow valves. They're almost exactly what I'm looking for. There's the big key.
Almost.
However, after looking at your EFV curve, I have some questions. I'm having a Goldilocks problem. The 25 liter a minute is too hard, and the 4 liters per minute is too soft. Do you offer these valves with in-between steps that the EFV curve leads me to believe? I want to keep my 1500 psi inlet pressure, and the 4 liter per minute is too close. It might work, but will require testing. So this one is for you, Corey.
Yes, and do we have the graph? Oh, I guess we'll start off. So this is our excess flow valve, and what it does is, if too much flow goes through it, it shuts off. Simple as that.
Hence the name.
When choosing these things, there's a few things. One that seems obvious is that you probably shouldn't put for an excess flow that your system can't reach. So say you have like 1/8-inch tubing in your line, you don't want whatever 50 SLPM.
Yeah, you're not going to get
You're not going to get that kind of flow, and it makes it useless, really, because you're never going to, trip it. So that's one thing to always keep in mind. And then the other thing is that it's an excess flow valve. And I don't know, anything to add? I guess I'm missing something. There's something else.
No, well, we have different ranges.
Different ranges, yes.
We got
the 4.
We have the A, C, and F range.
Yes, the A, C, and F range, which is 4, 25.
It depends on what.
Yeah, pull up the graph. Put up the graph. Yeah, this is what makes sense. So they're just nominal. So you can see we highlighted the A and the C. The A is supposed to be 4, and as you can see, if you know how to read these graphs,
they're hard to read.
0.1 to 1 goes 1/10 up each line, and then after 1 to 10 it goes up 1 each line. So if you go over, the lines are more. So it hits 4.
3, 4, 5. That's actually 6 on the A at 1500. So
yeah,
you got the bottom says inlet pressure. So you look at that. So the flow range is going to change depending on the inlet pressure, and then it shows you on the left it says the flow limit. That's liters per minute nitrogen.
And always make sure that you're using the correct units, and make sure to change them over if you need to. But so in this case, yeah, so for his was 1500, so we marked down the 1500, and at A, it's not 4, it's about 6, and for C, it's not 24,
No, it's about 25. So you got 10.
I was going to say 28. I was going to go closer. I was going to go 27, 28.
Yeah.
But it's close.
Yeah, it's kind of hard to read these things because I don't know the proper term. I call them double logarithmic scales.
Oh, yeah.
Because this is the way logarithmic scales are. They start out big and they get kind of smaller with the lines. It's a little bit crazy to look at.
I like these graphs. I don't know why. Yep.
Yeah, you like them. They're hard to read and hard to explain. But yeah, and this one, yes, there are. We don't make these ourselves. We buy them from a company that makes these, and they do have other flow ranges. Guess what? They have a B and a D and an E. And we just took their flow curve graph and
picked the ones that we
and just
thought
labeled
would be
the
best.
ones. Yeah. So I don't know who decided that, but that seems to be.
Oh yeah. This is been the case before.
Yeah. So there's other ranges possible. We just don't sell those. So this is the common ones we get. I think it's probably more the C's and the F's than the A's. But,
yeah.
And obviously you get the lower pressures. So that's part of it when you're trying to size it up. You could put it on the high, let's say you got a regulator in your system. You could put it on the high pressure side of the regulator, you can get greater flow rates. And you put it on the low pressure side of the regulator, it's going to be less flow rates. So you can kind of figure things out.
Yeah, see, yeah. If you have the A and the C, they have the same flow rate. A has the same flow rate at 1500, but C has the same flow rate at about 20.
Well, if you look at it, if you go, okay, so he's at the high pressure side. If you go, let's say delivered pressure 100, that's an easy line to look at. That A drops down from, 6 to 1. And then the C will go from 25 down to 7-ish, something like that.
Yeah, 7.
So that's a bigger drop. So yeah, so that kind of limits it too. Yeah, you can size things up depending on your pressure and stuff. So. Okay.
All right.
Okay. Oh, this is a fun one. Someone was talking about regulator reconditioning. So where do I go to get my regulator reconditioned?
Go to the hairstylist.
No.
Get some like I don't know, what's the big brands these days? I have no idea. I buy store brands.
Your hair's just so good. Well, the Compressed Gas Association, the CGA, has a publication E15, E for equipment, 15 being the 15th one they did. It's called the Guideline for Periodic Service Program for Industrial gas regulators.
Very, very brevity was the goal there. Clearly,
I worked on it. Yes, and it's I don't know. And I worked on this publication, so I get some blame for the long, lengthy title on it. It suggests that pressure regulators with elastomeric, common term, rubber type parts be serviced no more than 6 years after manufacture date, and then every 5 years after that. That's because the elastomeric materials, I don't think anybody really uses that word, will deteriorate over time.
you're just upset because you're having a hard time pronouncing it.
It's like
Elastomeric.
that's the right term for it.
It is, yeah. Just use elastic materials. It's just short. I call them elastic
rubber,
materials.
Rubber materials deteriorate over time. So we have our model 81,
Old-timey.
1881, 3320B, 3470, 3700, and the 3060A series all have elastomeric diaphragms. We don't know any standards. I don't know of any standards that would deal with stainless steel regulators. So I brought, where'd my diaphragm go? Oh, it's right in here.
That's right there.
So this is an old regulator. Where did we get this from?
From our carefully curated museum.
Yeah, you want to zoom in? So this is an elastomeric diaphragm, and as you know, if anybody has experience with rubber stuff over time, they can get brittle and crack. So that's kind of critical to get it checked out. Yeah, sometimes these things will last for decades, and sometimes they won't. So it's important. Yeah, it's important to service these things if you want to have them.
It's like getting your cylinders. Cylinders have to be tested every so often. When we,
Yeah, they do. So that's kind of it to look at that. And we don't service regulators here. Actually, it goes on this way.
This is why we don't service regulators.
Yeah, no, people working in the back know how to put.
Yeah, I know.
Actually, fits better when it's there. But yeah, it's a lot of stuff going apart. Now we're just not set up to do reconditioning on it. They're different repair shops. There are outfits that do that. Maybe call customer service. We'll recommend different outfits for that. That's good. And like I said, the stainless steel diaphragms are not going to get brittle over time.
No.
Your biggest failure with those are probably going to be creep.
Yeah, something gets not an actual diaphragm failure, but some particulate gets in between.
You get particulate in there.
Yeah,
something
so it's
like
actually it's just a.
But if you get those that are not acting properly, then you probably need to get them checked out, or just get a new one. So.
And we'll sell you a new one.
Yeah, we'll sell you a new one. Yes. Well, that's all the questions we're going to cover for this week.
Oh, there you go.
So there we go. Just another episode of the Bill and Corey Show. We'll probably do
Leftovers on Monday.
Yeah, probably going to do it on Monday. It's going to be nasty weather tomorrow. I don't know if we want to come in just for doing that and stuff. So yeah, we'll probably do a Leftovers of Bill and Corey on Monday, and we will not be talking about how well the Steelers or the Eagles did over the weekend.
No.
Because they're not playing football this weekend.
No.
They might be golfing down in Florida or something. So.
Yes.
Oh well. So thanks. Tune in again next week for another live episode of the Bill and Corey Show.
Set your VCRs.